Given functions qx equals 1 over square root of x and h of x equals x squared minus 9, state the domain of each of the following functions using interval notation. So when I take a look at number a is q of x over h of x, which that equals 1 over the square root of x over x squared minus 9. So to simplify this, this would be 1 over square root of x times x squared minus 9. So now we're going to look at where the domain for this function is. Now when I look at this part of the x here, I know the domain for that x is x has to be greater than or equal to 0. And then when I look at this one here, this is all real numbers for the domain of x squared minus 9. But we're talking about where this function altogether is undefined. So what I see here is where the bottom is 0 is where we're undefined at for x. So what I can do here is I can look at this idea first. So I'm going to look at the square root function first. And I see here that if it's equal to 0, the bottom will be 0 and we can't accept it. So really what I have here is x is greater than 0. Now this isn't our answer yet, but this is our way there, a direction there. Okay, so now when I take a look at the next piece, what makes that 0? So I'm going to take x squared minus 9 and find out where it's 0, and it's those values I can't have. So I'm going to move the 9 over first. That's going to be x squared equals 9. Square root both sides. So x is going to equal plus or minus 3. So this tells me x cannot be negative 3 or positive 3 or 0 because of the square root. And it has to be greater than 0 also, because we can't get any imaginary values here for the square root of x. So we have to be careful in that. So now that means for our domain then, and I'm just going to try to illustrate this on a number line, and this usually helps me a lot more to solidify my answer in terms of interval notation. So I'm going to put a 0 on here, and I know I have to be greater than 0, so I can use a parenthesis here. I can't be negative 3 or positive 3. Negative 3 I don't have to worry about because it's over here, and I'm greater than 0. And the next part is positive 3. So honestly, all I need here is 0 to 3, union, I'm jumping 3, and then to infinity. Now I don't have to worry about any of the negative aspect of the real numbers because I'm dealing with this square root here. The square root specifies in its domain that it has to be larger or than or equal to 0. But it can't equal 0 because that will make the bottom 0, and we can't have 0 on the bottom, so we have to take the equal 0 away from that. So that's why I have a parenthesis here. So that's our answer for our domain for the first problem. So now let's clear this all out and we'll do number B now. Okay, so then for number B, we're going to take Q of hx. Now again, we're all pretty good at using our notation to figure out what we have to write here. So Q of h of x is going to be 1 over, and then I have this square root, and then my h of x, I'm going to plug in, or for my q of x, I'm going to plug in x squared minus 9 in place of x. So this is going to give me x squared minus 9. So there it is. So now I have to consider this domain of this function here. So originally, it says here that x is greater than 0. And what I have to go back to is the definition. Take a look at this. It says the domain of the composite function f of g is all x such that x is in the domain of g and g of x is in the domain of f. So this would mean that what's under here cannot be equal cannot be equal to 0 or less than 0. So it has to be positive, the x squared minus 9. So just going back for a second to try to put this all together. When I go back to this definition, it says the domain of the composite function f of g is all x such that x is in the domain of g and g of x is in the domain of f. So when I go back here, this h of x has to be in the domain of q. So when that tells me then that this down here has to be greater than or equal to 0. So x squared minus 9 has to be greater than or equal to 0. Not even equal to, because it's on the bottom. I can't have 0 on the bottom, so it's simply greater than 0. So I can move the 9 over, x squared greater than 9. I can square root both sides. And that changes things a little bit. So I'm going to do this instead. I'm going to take it a step back. I'm going to say x plus 3, x minus 3 greater than 0. And I'm going to think about the idea here of the polynomial inequalities. So I'm going to plug negative 3 in here and 3. And I'm just going to determine on which intervals I'm positive. Okay, so I'm going to pick negative 4. And I'm going to pick 0. And I'm going to pick 4. So now what this means here, when I plug in a negative, that's going to be negative 4. And that's going to be negative. Negative times negative is positive. So that tells me here is positive. And then 0 is going to be negative because, I'll put it down here, negative, because when I plug in a 0 here, that's positive. When I plug in a 0 here, that's negative. Positive times negative is negative. And then I'm going to do the last one here at 4. And this is going to be positive, and this is going to be positive here. So that tells me that this is positive. So it's going to be positive for x negative 3, well, negative infinity to 3 and 3 to infinity, not including 3 because that's where it equals 0. So then to write the domain out here, it's going to be negative infinity to negative 3, not including 3, union 3 to infinity. So there's our domain for number B. A little more complicated than the first, but I'm still looking at the idea of where this here is 0. Now let's do number C here. Now what we're doing with these problems is really nailing down the idea of domain here in general when we talk about composite functions. So now we're going to take h of q of x. And that means we're going to have, instead of the x, 1 over square root of x squared minus 9. Now, before we get started here, let's go back to the definition again and what it means to talk about the domain of the composite functions. So the domain of the composite functions, f of z, is all such x that x is in the domain of g. So x has to be in the domain of g first. And it says here, which is a conjunction, which means that's true. And then g of x is in the domain of f. So now when I look at this, before I start, I have to look at x that's in my q of x here to relate that to the last, to that definition there. So that means right away, I'm dealing with x greater than 0. Now I can't say equal to because it's on the bottom here, and I can't have 0 on the bottom. And now that's my domain of q of x. And then it says and, right? That was a statement I used. And my q of x has to be in the domain of h of x. So now I have to ask the question, is that going to cause any problems for me for q of x being plugged into h of x? So when I simplify this, I'm going to get 1 over x minus 9. And if you think about the domain of q of x already, it's just this here. When I plug any of those values in into my q, And are those values going to be, these y values, are they going to be anything that's not in the domain of this function here? And everything works except for 0 for x, and that's already excluded by my first exclusion. So then that means for us that we're just going to be greater than 0. So again, I can't include the 0. So it's going to be 0 to infinity. So there's our domain for the function h of q of x. And that's interval notation.